forensic science, it's an awesome field because it's a very explicit way in which statistics is used in the law, and it's done, or it has been done, in a very problematic way. You know, the law requires finality so that cases be done and are not revisited over and over and over, and certainty. Right, in the law, you have to be certain that you're putting the right person away in prison or that you're letting the right person be free. And in science, we deal with uncertainty. Like, that's kind of one of the main currency of statisticians, is quantifying uncertainty. We embrace the error, we embrace the uncertainty. My name is Maria Cuellar, and I am an assistant professor of criminology and statistics at the University of Pennsylvania. We've encountered in recent years, ever since DNA started being used, we find that there's been a lot of errors in most forensic science disciplines. And the National Academies of Science published a report in 2009 that was very explicit about saying there are a lot of problems here. We need to revisit the way forensic science is happening in forensic labs, and we need to quantify the uncertainty. The Innocence Project has been very influential for me. It's a non-profit organization, and they focus solely on exonerating individuals. I was a postdoc still, and there was a talk that was given by an exoneree. I showed up, and there was this guy with a big white beard. Sort of thought, this guy must be like a math professor or something. And he turned to me and he's like, "Who are you?" I'm like, "Oh, hi, I'm Maria, you know, nice to meet you." He's like, so what do you do?" And I said, "I'm a statistician." "Well, what do you do?" And he said, "I'm a statistic." I was incarcerated while being innocent for 33 years. And then he gave this talk. There were like maybe 200 people in the lecture. And as he was speaking, I just have never seen everyone in the audience just crying. I think there's the element of just feeling like, you know, you're innocent of a crime and someone made a mistake somewhere and then they're putting you in prison. And everyone you know thinks that you committed this. It was a horrific crime, it was a murder. And not just that, but you know, at this time, this man was incarcerated. He was a false positive error. But it was also a false negative error because the person who really committed the homicide and rape went free. And so it was a double error. And I thought, you know, maybe I can work with statisticians to try to prevent some of these kinds of errors from happening in the future. And so that really guided me and motivated me to work more on forensic science. I came up with this idea to study tool marks, and that originally came from an Innocence Project case. It was a bomb case. A man was found to be guilty, and there was very limited evidence that pointed to him. He had bought the anarchist cookbook at a bookstore, and the bookstore owner thought that was very suspicious, so the police looked into him, and they found that he owned some tools in his house. So he owned like wire cutters and some other just regular tools. And an examiner matched his wire cutters to a wire from one of the bombs. And it's a 1 millimeter long wire cut, and that is what convicted him. The interesting question in forensic tool marks is about whether two marks, one from a crime scene and one made from a suspect's tool, whether they were both made by the same tool. But the way that this is done today is that examiners will generate some test marks with the suspect's tool, and they'll compare them with the crime scene mark under a microscope. So they'll only really see the image in 2D, and they'll look at it and say, "Oh yeah, that looks similar enough to me. I think this is a match." It's completely subjective, and there's very little information about uncertainty with this. And so I thought, okay, we need to do this in an objective way. And what we need for this, first of all, is data. It's very hard to get data in forensic science. There's a ton of data out there, but it's not very high quality, and a lot of it is from casework. And so we needed experimental data. So I thought, let's collect data. It seems like it'll be pretty easy. But then I thought, okay, we want to do it in a controlled way. So I thought we need a machine. And so this became much more complex, ended up taking about 3 years. But because this happened during the pandemic, I had to do things in a kind of roundabout way. I ended up building a laboratory in the basement of my home. And this was the same time when we were teaching from home. And right before this time, I also had kids, twin babies. So they were going around in the first floor of the house and like banging stuff against the floor so I could hear it from the basement. And then my husband was, because he's a professor as well, he was teaching in the second floor. Thinking back on it, it sounds very interesting, but at the time I was like, what am I doing? This is like, it doesn't make any sense. I should be like in a laboratory. But I was very careful. I documented everything and we got a cool data set, and I'm still working on analyzing it now. So with this machine, so if you want to stand over here and you can press this button, you'll see how if the screwdriver were all the way down, it sort of scratches the surface. Okay. And then if you want to try out pressing it onto that mark, so you first kind of press it and see how good it looks. So when you click the button, it took 6 different pictures with 6 different cameras and flash. Oh, so it's sequential. And then it takes all of these, and in their software, it makes it into one 3D image. Okay. Doing expert witness work, I've really loved. Because the law works by setting precedent, if I say something kind of correcting the record, that can be used in the future in new cases to do things the right way. And so I feel like I'm not just affecting that one individual's life, but also maybe future individuals' lives, and that I can help prevent these same errors from being made in the future. My new project is about facial recognition and how it's being used by the police. It's a similar question as in forensics. For example, with fingerprints, the idea is, are these 2 fingerprints, one from the crime scene, one from the suspect, from the same finger? And in facial recognition are these 2 images, one from a database and one from a crime scene or whatever footage they have, are they from the same individual? And it's very similar in many ways, but it's also very different. In facial recognition, the data is faces, is facial images. And so when there are errors, meaning that the algorithm finds the wrong person, there are different error rates for different subpopulations of individuals. So for example, the algorithms generally perform worse with women, and they tend to perform worse with some minorities, African American individuals, Asian individuals. And also, the algorithms are getting very good. They're using artificial intelligence. It's just a very quickly changing field. There was a study in Baltimore that found that out of 100 cases that the police were studying, only 1 used DNA, but 50 of them used facial recognition. And so this is just like going to be very common nowadays. And we have very little idea about how the error rates change when you go from ideal conditions of like laboratory, beautiful pictures, high resolution, people facing the camera and so on, compared to the images that the police are actually using. And furthermore, the way that the police are using these is unknown up to most of us. There's been a little bit of research on this, and they find that the police are pre-processing the images a great deal. So they will Photoshop eyes from a high resolution picture and put them on the image from the CCTV footage and put that in the database search. And so my idea is to study error rates and accuracy measures in realistic use of facial recognition by police. Because right now we have kind of idealized error rates, but what we need to understand is what's actually happening on the ground. I think something cool about statistics is that we're sort of meta scientists or something. Like we're kind of working in helping answer scientific questions in different areas. And so maybe from that vantage point, we're able to see connections between the areas in a way that someone who's like within a specific field might not be able to see. So that's really fun for me, although, it's challenging.